Today we're going to talk about polygons and how to figure out what the sum of all the interior angles of any polygon ever is. So I have three polygons behind me. This one's a triangle, this one's a quadrilateral, this one's a nine-sided polygon. Notice they're random, there's nothing special about them, not an equilateral triangle, not a square, and not a regular nine-sided polygon here. We've previously discussed with triangles, the triangle sum theorem. We know that the three angles within a triangle add up to 180 degrees. That's not new, so we're not really going to explore that, but I wanted to remind you of this. The three angles, this one plus that one, they must add up to 180 degrees. We've discussed that at length previously. A four-sided polygon, any quadrilateral, we haven't discussed this directly, but if we divide this up into two triangles, I'm hopeful that you can see pretty quickly that two triangles here, if this stuff adds to 180 and this stuff adds to 180, these three angles and then these other three angles, well, of course, 180 plus 180 is 360 degrees. Well, is there any rhyme or reason why this works? Like, what if you have a 9-sided polygon? What if you have a 20-sided polygon? What if you have a 100-sided polygon? Do you have to draw it out? Do you have to create triangles and try to figure some stuff out? You could, but there is a shortcut, and we're going to kind of explore that here. So I'm going to go ahead and open up these moves just because it's a much better way to see what's going on here. So I've created a few shapes. Here's a triangle, here's a quadrilateral. Notice again, not equilateral, not a square, and then I have a 9-sided polygon over on the right-hand side here. So what we're going to do is we're going to explore here. Reloading. Cool. There it is. Okay. So these already put the angle measures in. They add up to 180. No surprise. These add up to 360. If you do 62 plus 127 plus 80 degrees plus 91 degrees, you'll get 360. I'm not going to dwell on that right now. What I want to explore is this 9-sided figure. I know it's not exactly like what I have on the board behind me, but it's a 9-sided figure that's not regular. It's just an awkward shaped thing here. So I'm going to go ahead and use this angle tool to save me a ton of time. And what we're going to do is click on 3 points, and it's going to tell us, for example, the measure of this angle is 153 degrees. So as I'm doing this, I have my calculator out, and I'm adding up these angle measures just to see what we can see. So the first one is 153, and then we're going to find this angle measure, which looks like it's 157, so I'm going to add that. And then we're going to add that one to whatever this ends up being, 113. This is going to get a little bit monotonous, but I'm going as quickly as I can assure you. So we got 145 on this angle. Right, we got 135. This angle tool is a huge help. Otherwise, we're using protractors, and this is taking significantly longer. I just added 124 to my running total here, and then our 9th and final angle is 127 degrees. So on my calculator, I got 1081. It's a little awkward. It should be 1080. The reason it should be 1080 is because on these moves, these aren't necessarily exactly 153 degrees, exactly 157. They round to the nearest whole number. So some of these are like a 0.5 or a 0.3 or whatever, and it ended up rounding up to 1081. So not perfect, but the sum of these 9 angles should be 1080 or 1080. So I'm going to go ahead and transfer that information up here. Oh, 1080. Forgot that number right there. All right. So what can we take away from this? Well, I'm going to cut right to the chase. We're not necessarily going to discover this formula together, but I hope that you see it. So you can tell from the number of sides that a polygon has what the sum of the interior angles is, no matter how they're arranged. Like this is kind of a wonky one. The one on the Dismus was a wonky one. It could have been a regular 9-sided polygon, and we'd end up with the same thing. So all you need to do, and we can verify it with these three, is if you have the number of sides that your polygon has, for example, it's either 3 or 4 or 9 or whatever you're working with, you take that number, you subtract 2 from it, and then you multiply that by 180. This is the formula to find the sum of all the interior angles of a polygon. Let's check real quick just to confirm that it works for R3. For example, a triangle. triangle has 3 sides. So if we plug that into this formula, we would do 3 minus 1. No, that's not true, because this is a 2. 3 minus 2 times 180. Well, 3 minus 2, of course, is 1. 1 times 180 is 180. That one checks out. Let's check a quadrilateral. Now we got 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 is 360. That checks out. Okay, here's the wonky one. 9-sided polygon. 9 minus, yikes, I keep jumping the gun here. 9 minus 2, got to follow the formula. N is 9 in this case because we have 9 sides. 2 is 2 because that's what the formula says. And then the 180 is 180. So 9 minus 2 is 7. 7 times 180, I don't remember that off the top of my head, so 7 times 180 on my calculator, and it tells me that I got the wrong answer. What did I do wrong here? Let's go look at our polygon real quick. I am starting to think that what I did here is, I don't think this is a 9-sided polygon. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. So what I have done here is I told you this is a 9-sided polygon, but we can clearly see it's an 8-sided polygon. So what the takeaway from that is, if we have an 8-sided polygon, we can verify this real quick. So I did not actually find that. I found one for an 8-sided on the Desmos, and that's where I got my 1080. So if we replace this with an 8, 8 minus 2 is 6. So 6 times 180, that's where we get our 1080. So that does check out. So for any octagon, think of a stop sign. You can add up all the interior angles, and you will get 1080. 8-sided polygon is 1080. Okay, because I made that mistake, we have some exploring to do. What about a 9-sided polygon? Let's check it out. So we're going to follow the same formula. N minus 2 times 180. Our n in this case is 9. 9 minus 2 is 7 times 180. This is the number we just came up with. So 7 times 180 is 1260. So the sum of these 9 angles is 1260 degrees. 7 times 180. Okay, that was a little clunky, a little messy because I mixed up my 8s and my 9s, but I'm hopeful you get the picture here. If you have run into any questions, let me know. You got this.